All right, well, we're back in Houston. Can you tell? With Kurt Neubek, who is always so totally prepared and has thousands of things to be able to say especially about the choice of materials and the dynamics of the glass reflectivity, the heat retention, and so forth. And this is the hat trick episode, and it'll also be part of our class, because this is so important if people are going to design their own or learn why things cook or don't cook. What do they got to do? So I'm just going to go ahead and take it away. Kurt, what do you have here? What do you have to show?
Well, thanks, Luther. First of all, thanks for coming. And just a quick recap of why do I do this? I don't know. It actually goes back to in grad school. I studied solar architecture, and back then the Passive Solar Handbook was brand new, and I was doing a lot of computer programming for the university, programming that. So I was able to run a lot of simulations with passive solar buildings and understanding how do you optimize a building. So I have a kind of inherent understanding of how these things work. So when I first started getting back into this a few years ago, I built one for some Boy Scouts, for Boy Scout outing, and then I decided to, then it became a hobby. And I said, well, I know how to build a really effective cooker, but for some reason I was drawn to, well, why don't I kind of lay out the foundation, the fundamentals? And so I keep going back to that. And, well, I'm going to jump ahead briefly, because I was doing these box cookers early on, like last year and a half ago, and just simple boxes just to show people you can start with really simple materials and get them to be cooking temperature. And I varied the type of glass, and changed the outside, and I was tracking all those things. And I was using generally this signals. I like the probes, because I can track 4 different cookers at the same time. And in fact, I have 2 of these, so I can track both the box, the temperature of the water, if I have a pot of water, and the temperature of the water, and the temperature inside the box. And those, I can graph those and get the data, and I really like that. So that especially for just being kind of scientific and be able to show what is the difference and introduce some variables. I've also more recently found this called Meter, which is a wireless probe, and these are meant for cooking turkey or anything, and so those are really handy. So I used those at the beach last time we were out. Most recently, one of the things that I was doing, and I posted on Facebook, I did a series of experiments just in the sun, of course, starting with, again, fundamentals. Start with a Pyrex clamshell, and as you know, graniteware pot fits in there, whether it's a graniteware lid or, in this case, I use a glass lid because one of these probes fits in here really nicely. And then I don't know where I got this the O-ring thing to. Oh no, it came with the pot. It came with the part of the pot lid. And so I could suspend this at just the right height above the water, and then track how's that doing. So I did a series of these where I put it, I think, just on concrete, and then this is just a sheet of cheap aluminum that is Home Depot, and then I had some much more expensive, more reflective aluminum, and I had a series of these where I changed different things. I had the typical Pyrex, which is rather green as glass goes. As you know, glass has iron in it, which makes it green. So you can get iron-free or low iron glass, which is less green and therefore clearer. So I had some of these. I had some bowls from France, LYS brand. It'll kind of like this. They didn't have the big lip. They don't see as nicely, but they're much more clear. And one of the things that those experiments showed was that getting it up off the glass, so it's not touching the glass, helps, even if it's just this much. So I have a little stand in here. I just have it upside down to be able to get everything to fit in here. But getting it to keep from touching the glass is presumably the glass is cooling it off, getting some convective losses there. So there were a few things there, and Tom Sponheim saw it and said, "Oh, be sure you send this to Paul." And so Paul set up a website or a page on the wiki so I can post these things. I haven't done yet, but I will. There's a series of experiments there. And then this, you might recognize this. I like this because it's the biggest glass bowl I could find. And for example, the Haynes pot fits in here, but it does not fit in a Pyrex bowl. No. So it fits in here nicely. And this comes from a relatively low cost air fryer. And so the thing and I bought 2 or 3 of these locally used for $30 each, because I looked into what it would cost to buy the glass, and I could just buy the whole thing working for $30. So I picked up a couple of those, although I will say someone else posted something recently, and apparently they're more rare now. The ones that, the latest style for these air fryers is almost like a coffee maker, where instead of a pot, there's a basket there. So this glass style is not as easy to find as it used to be. But I got a glass lid, or some people I've seen online will take this part, which is essentially the heating element, off, and use this, but they take the heater off and put a separate little glass pot in there. But the thing that's interesting about it, 2 things: it's the biggest glass I could find that's tempered, and then this too, you want to get up off the ground, and it turns out the higher you can get it, the better. And I'm sure that's because the light is going to be reflecting to the bottom of the pot. Yeah. We all know if you wanted to heat up a pot on the stove, you want, well, anywhere, you put the heat underneath, because the heat rises and it's going to heat the pot. Whereas if you had a blowtorch, if you just held it on the side, it would take forever if you just heated the side. So the idea of getting the heat underneath it does make a difference. And neither of these, just sitting out like this, got up to cooking or boiling temperature, but they definitely raised it, and there were some noticeable differences. And of course, the other thing that's nice about this is, if you wanted a hybrid, there you go. Now it's a hybrid. You can plug it in if you need to. And this is very effective. It's like underneath here, if you take this apart, there's a heating element. It looks just like an electric stove. Oh, sure. And a fan. So that's how it just blows hot air down, is how that works. So I have a series of those, and those have been fun to do. And then even thinking further about, and I did some variations. I thought, well, what if it wouldn't surprise me if getting this up and then actually insulating the top might be better. Go ahead and let all the heat come in, but only insulate. So now it's kind of a hybrid hay box and solar cooker. And this, because this is commercially available from hotels and restaurants when they serve the food in like room service. Sure. That's the lid that they use. So I was able to get those commercially available. I thought, that's a nice fit. But because I thought, well, rather than making it out of insulation, these are. I like the idea. Is there something commercially available that works there? So I haven't tested that yet, but I will. And you can see in this case, it doesn't quite fit. Yeah. But so I'll either have to. Actually, I think in this case, no, I don't. Yeah, I do have so I might have to give that up. It fits without the rack. So I'll do some other tests there and see what happens. Yeah. So that's got one series of things. Oh, and then I also found, I don't know if you've ever seen one of these, there's this cooking pot, I'll probably show the picture here, this cooking pot with these fins on it that's supposed to heat up better than regular pot. So I picked, one of these days I'll work that into rotation and see if it's any noticeable difference. It seems like I could imagine that working. When I see the photo, the infrared that they have there, that's their marketing. That's to show how the fins can spread it further up the pot. Yeah. So to the second chapter, I want to go back to the box cooker, because as I mentioned, I liked this. I started with this just because it's so simple and easy. And one of the things that I knew or learned was that, well, I knew, but became really apparent when I was doing this testing, is that standard glass samples come 12 by 12. And 12 inches by 12 inches. And so I thought, well, I can get cardboard boxes that are 12 by 12. Maybe that's what I'll do. Get a bunch of 12 by 12s, insulate those, and start some variability. But then I thought, well, it's okay as an initial test, but I'd like to get a better metal box. So I was looking, again, rather than making one out of a big sheet of aluminum and cutting it and riveting it or something like that, I was looking around, are there any commercially available boxes? I was looking, are there planters or looking for open on one side, or waste baskets, 12 by 12 stainless steel, and I was surprised I didn't find any. But I did come across these lockers. There's a regular sports locker, 12 by 12. And I thought, oh, that's interesting. I'll bet I can buy that for less than I could make one.
Yeah.
So that's what I've done here is that, and I have 4 of these now. And so I like to do it the locker door. And then the idea is I'll cut a hole in here, and the 12 by 12 glass, of course, fits on top of here because this is 12 by 12. So I'll cut out a hole, leaving probably a ½ inch or 3/8 maybe for a frame, be able to hold that secure. That'll be a gasket in there, and that way I can try some of the things out. And even with the Haynes pot, so I've got a Haynes in here, which of course is bigger than the granite ware. This will even fit in there and swivel. What I'm picturing on these is I'll put alt-azimuth, so I'll have a standard yoke, as they're called, so that this can rotate this way, and then that will pivot around to follow the sun.
They call that a gimbal or gamble?
Well, yeah, it's kind of. So the gimbal is, my understanding of the gimbal is a little different, but the yoke style to rotate that. It might technically be a gimbal, and then there would be a tray in there, like so many other cookers, so that as you tilt this, then the food stays level. So I like this idea very much because I can try, the box will be identical, and then I can try different kinds of glass. So as an example, I've been using on these, this is the clearest glass I could find. This is actually a cutting board, 12 by 12 cutting board that I found. And then I had also some clear glass, but when you buy so-called clear like this is standard solar band, tells you a little bit, but it says clear, two sheets of clear, but the visible light transmission is only 64%. Again, you can tell it's kind of green, so if you get the ones that are not so green, so here's an example. This one is this brand happens to be called Starfire, which is the less green. It's the low iron. So this is 71% going through the 2 of these. So so that's better. And then I showed you this last time you were here, but now I can use, this is 12 by 12, again 12 inches by 12 inches. This came from China. This is vacuum glass. So this is 2 sheets of glass with a 0.3 vacuum in between the glass. And the way they do it, I've read about it. I don't know this brand in particular. That one of the things that they found is it's understandable. If you had 2 sheets of glass and you put a vacuum in between them, they're going to bow and close up, and then you lose the insulation effect. So what they do is they put little dots, they call them, or columns sometimes they call them, spread around in there, and it keeps the glass apart. Yeah, you can actually see them. There's a little grid in there of tiny little dots, and that's what holds the glass apart.
Let me get the white behind it so I can see it. Oh yeah, okay.
So I'm eager to see if what's the equivalent insulation value of that.
Yeah. That can't be what, 1/8 of an inch maybe?
Yeah, that's surprisingly small gap, I thought too.
Yep.
Now, one of the things that and this is just happened to have grabbed the Rockwell was here because what I pictured, put the yoke on here and then wrap the whole thing in insulation, even the door, of course, insulate everything. And that's something else I'll vary, 2 inches, 4 inches, and really change how much insulation. Keeping the glass the same, if you change the insulation, what's the difference? Or keeping the insulation the same if you change the glass. Do some scientific tests with it. But one of the things, as I mentioned earlier with the building modeling, that became apparent to me is you want to increase the ability to get the heat in, but reduce the losses. So in other words, you want to get if you can have a window, you want it the best insulation value you can. I mean, there is a limit. You can have triple glazed or quadruple glazed, but because you lose about 10% every time, at some point, you know, the lines cross, and so that's why it's probably only 2 or 3 panes is probably the maximum.
Yeah.
But the other approach would be, what if you minimize that? So I also picked up this.
Oh, yeah.
So I'm thinking, well, what if I put a relatively small hole in there, and then with a Fresnel,
Oh man.
able to get it to go through that hole. And again, I'll just, you know, have to set up that this will be tilting to follow the sun as well. But the idea, and maybe I can even go smaller than this one, but I happened to find this somewhere and thought, oh, that'll work.
Yeah.
So if it's not obvious, what happens with this, the sun's rays that come through here, you understand, but as the sun comes through here, it focuses all these on one point.
Right.
So if you were to put like smoke here, and you can see it, it makes almost an hourglass shape with the sun. So if you get that hourglass to go through here, and as long as it doesn't melt the glass, then it will splay back out and fill up the box.
Sure.
So that's the idea. That I'm sure I'll do at least one of those. Well, I will with this one, and really super insulate this, and that'll be I may do another one too that has just a big cone here. Same kind of idea, but with a conical reflector instead of using the Fresnel.
Sure. I love that Fresnel. Where'd you get that?
I just had a look online. This is the biggest one I could find. It was under $100.
Sure,
when you get bigger than this,
is it glass or is it?
No,
plastic?
I'm sure it's plastic.
Oh, sure. Yeah.
So, yeah, that was, I just looked around, until I could, found something. I said I wanted it as big as I could get, but, you know, they quickly went over 100, 200, $300. I thought, I don't need it that badly. Plus, I would like to get it to where the area of this is roughly equivalent to, in fact, maybe what I'll do is I'll mask this off with the first test and make it 12 by 12.
Yeah.
So I can do a real side-by-side comparison of 12 by 12 input versus 12 by 12 input without any reflectors. But this one, because it will have more insulation, it will almost undoubtedly perform better.
Yeah.
So. All right. So this last chapter, I go back to the fundamentals of the Pyrex bowl, and you may know. Well, you do know when we were together for the Sandcastle event here, for the solar cooking demonstration at the annual AIA Sandcastle competition in 2023. I bring out an array of cookers. I have a number of others that I don't have out today. Commercial cookers. I have Haynes. I have a Copenhagen. Scott Rundle's. I have a box cooker. And I have great big parabolic, so wide variety. I also have one of Tom Hallquist's, you know, but I also put on that one, I rigged up one of Stan Wells's trackers onto Tom Hallquist's cooker. So it would rotate and it would also tilt. Now, as you know, with Tom's, the food doesn't move, but the reflector would still tilt to follow the sun. And Stan sent me one of his trackers, which I've taken apart and reused on a couple, and that was the last one on Tom Hallquist. So the way Stan does his cookers, it's 2 axis, because generally when you're tracking the sun, there's, again, alt azimuth. The same thing is true with telescopes. If you buy telescope, they often have what they call altitude and azimuth, which is this rotation. And so it has 2 different motors and 2 different axes that it's tracking. One is just up and down, that's altitude, and azimuth rotates. So that's very common, works great. But that's not the only way to do it. With telescopes, there's something called an equatorial mount. With a telescope, you basically aim the telescope perpendicular to the North Star, if you're in the Northern Hemisphere.
Sure. But
essentially what you're doing is you're setting up the rig to be parallel to the Earth, or more parallel to the axis of the Earth. And so if you're at 30 degrees latitude, which we are here, that's different. Then, of course, it changes as you change latitude. So here's an example. This is a little sundial, and this particular one, so this start facing south here, and with this little gnomon here, this would cast a shadow, and this shows you the lines of what happens. If you leave this facing south, the shadow would move across, and depending on the time of the year, When the sun is lower, it would cast a shadow near the top. When the sun is higher, it casts a shadow near the bottom. So, and then of course the equinox is right in the middle. So this is just, I got this off of, I think it was astronomy.net. I should check that before I say that. But and this one I just printed on typing paper, but you cut it out and you tape it together and it makes this little bowl, and you pick it for your latitude. Well, I got to thinking about, well, what would it take to make, could I make a single axis cooker using this? That was the question. What would that look like? And I did a lot of sketches. I should have brought my notebook. I did a lot of sketches over time, thinking of different ideas, and some of it was based on just putting the pot like this. And by the way, this is very similar to the Simplicity, but yes, I beefed this up. This is not directly from the Simplicity, but very similar, so that it'll hold the standard Pyrex. And so I thought, what would I do with that? And we've talked before about the gimbal, the idea of if you had this, and maybe I should have pulled that out too. I made a gimbal. You have this, and then there's basically another ring or a square which pivots the other way, and then that allows, even if you rotate the base, the pot will stay level. Just like on a boat, if you have a cup holder, for example, same idea. That's how this works. So, got to think about what would all this do, and studying really the astronomy and the path of the sun. What would that look like in a cooker? Well, that's where this comes. So the idea with this is you set the latitude, just like this. So you can see right now we're at 30 degrees latitude. But if you're at the equator, you would do this, and I have a little scale here, so if you're up in Minnesota, you can do that, or if we want to go up to the Arctic Circle, there's a line for the Arctic Circle. But to give you an idea, what happens is you set the latitude first, and then this is the path of the sun. At the equinox, you would set this in the morning, and then it does this. If you put the food here, of course, put the food in the middle, and you can just move the reflector. And then it turns out there are seasonal differences. So if it's December, there's this tilt, and again the food goes in the middle, but it follows that path. Or if it's in the summer, so I have another scale over here, you adjust that and rotate that around. So let's set this to Houston at 30 degrees. So set the latitude at 30, and then you aim this toward the equator. We'll assume for the moment the equator's that way. And then you want this roughly level. I have it on wheels, but I also have some little leveling legs, and a little oh sure, a little level there. It doesn't have to be perfect, but if you were on uneven ground, these might be handy. For example, when I'm out in my front yard in the sun, some of the sidewalks are kind of tilty, so I'll use that. Might come in handy there. So, but you set that once, you aim it toward the sun, you set the latitude once, unless you move it around, and then you decide what time of year is this. So of course we're right about June 1st right now, so set that there, tighten that up, and now this tracks by day. This would exactly follow the path of the sun. This would always be perpendicular to the sun, and this would rotate 15 degrees an hour. Now when you're doing latitude and longitude, or alt-azimuth I should say, it's not exactly 15, but in this direction it's exactly 15 degrees an hour. Why 15? Because 360 degrees in 24 hours is 15 degrees an hour. So that's how the Earth works. Now I've seen this looks a lot like there are telescopes are fundamentally based on this. I didn't invent this. I just adapted it really from telescopes. There are, as you saw, essentially sundials do the same thing. This is another form of, very much a form of this. Ooh, I brought this out. And then I also saw that Brian White in Canada had posted something fundamentally like this. It didn't look like this, but he was talking about the same ideas 10 or 12 years ago, a YouTube video. So then the question is, well, how do you keep the food there? And I thought I originally thought that I would mount it here until I built it, and I realized, well, no, sometimes with the sun here, so now my current thinking is I'll continue this arc here, and this will be a circle, so that there will always be a place you can suspend this exactly centered in the pot.
Oh, yeah. Yeah.
Now, I also didn't explain why this pot. It's not a perfect parabola, and that too is because I was looking at what's commercially available that's very reflective, something like a parabola. And I came up with this, and they come in different sizes. They come even bigger, but again, these are like, smaller is like $40. This was like $75, but the next size up is like $200 or something. So I said, okay, this is where I'll use. And I have several of these, so I think I might end up bending it or deforming it and trying to make it a little more parabolic. Or the other thing is, of course, I could just get rid of this altogether and put in any kind of a parabolic dish, you know, make it out of cardboard or flute board or or aluminum, and drop an actual parabola inside the same dish, and see if the difference is very big. Because this is actually surprisingly, you'd have to look, if you know, if we put this pot right in the middle. I'm going to do it this way, it's easier. Can you see all the granite wear? Can you see all the black in the reflections?
Reflected in there.
So that's the idea. Yeah. That if you can see the black, well, especially if you were further out, if you were at the sun, then that's exactly what we're going for. And it's not quite as deep as I'd like because it has to be able to rotate. Yep. And so it's not perfect, but I figure, well, again, it's close enough. I'll try it out. Now, how do I get it to rotate? I've got some gears here, and I came up with several ideas. The first one was I found online a high torque 24-hour clock works. So for a AA battery, at least in theory, I could put this on here, mount it on there, and I tried it and it wasn't strong enough. So I'm thinking that I'm not sure it couldn't work if I had the right gear ratio or something. It might be that this needs to be a huge gear and then this needs to be smaller in order for it to be able to move it. But this would just move, you could just, with one AA battery, just aim it at the sun in the morning and it'll just track it all day. Now, the downside of that is that assumes there's no wind, there's nothing else bumps it. It has no self-correcting mechanism. It only knows to keep turning. So that's the downside to that. But in theory, it could work, and especially if I had some other kind of a mechanism to keep it from going backwards or something, maybe that could work. But then you get to what if I made a tracker? And as I mentioned, with Stan's trackers, he's got 2 axes, and this one is just 1. So I was trying to say, I mean, you know, I love Stan's trackers, and it's especially the way he handles the one he's got on his evacuated tube, where he's got altitude, azimuth, and he's got temperature control with a clamshell. Like it's not going to get any better than that. So I'm not trying to better that. I'm trying to say, well, is there another way? What might that look like? So the idea of single axis, and again, maybe this is more complicated than a south running one, but I thought if it were single axis, what would happen? So I put a little motor here, and what I'd really like to do is get this to be a mechanism like this. This is a single solar panel. Mount this on here, and if I could get everything working right, then you could do it. Stan does his with little PVs. I was using light dependent resistors in this case, but I'm trying to do it all much lower voltage and very, very simple. You know, there are people, you can look on the internet and find all kinds of people talking about using an Arduino to make a tracker. It's like, you don't need that. I think it works. It's just unnecessary. It's a very simple mechanism. There's one motor, and really the only thing electronic on this is I have a tiny little battery and this little mechanism that goes with the photo cell, with the photovoltaic panel here, to keep it charged up. So the idea is the panel would always aim at the sun, and only when the sun moves and gets more light on here would it adjust. So it's always recharging that little battery, and as long as there's sun, it'll be, and even when the sun is not there, these are pretty sensitive, so even if it's scattered clouds, it should follow it. Now, I don't have it all working. Technically it's working. You see the little lights on and everything. But this little motor I have here, again, I think it's mostly a gear ratio, or maybe I need different resistors or something like that. Because, oh, the other thing I did for this thing, online, I found some software. There's a company called Autodesk, which makes AutoCAD and Revit and Fusion and all these 3D modeling software, been around for decades. They have online for free some software called Tinkercad, and there's a module for doing 3D modeling, kind of introductory 3D modeling, and then you can move to Fusion if you want to move up. But they also have a section in there for circuits, which I just stumbled upon. And so I was able to test this, all my wiring, tested basically the wiring, my concept of how could I get this to do with one motor and only one panel. With two panels, I was able to do it with only two resistors. But I figured out how to do it, and it worked okay in the simulation. So anyway, that's my big idea here is, can I get this to, oops, would it be possible to make this a module that, oh, I'm sorry, I didn't say, one of the reasons I want to do this is, this could, whatever all this wiring I'm doing, this could be printed on one printed circuit board. Because nowadays, circuit boards, people make custom circuit boards all the time. You just draft it up, send it in somewhere, they print it and send you a pile of them. They're not very expensive. They can do small runs. You can wire up put the diodes and things on that you need yourself, or you can have them do it obviously for more money. But the idea of doing relatively low volume printed circuit boards, if I could do it, if we, the industry, had a printed circuit board to do tracking all in one piece that you could bolt onto a gear like this, well, maybe there's something there. So that was a reason for exploring this. And then I have a couple other different, right now I have this tiny little motor in here, which, like I said, wasn't quite powerful enough. It works, I got it turning, but wasn't quite powerful enough. So that's probably gearing. I have some bigger motors, and this is the style that Stan uses. So I know it can turn a wheel. This one is 6 volt. I was doing 3 volt right now, but this is 6 volt, 3 RPM, so it's very high torque. I'm sure it can turn it. Probably I just need a bigger wheel. But so there you have it. That's the quick rundown of what I've been doing since you were here last.
Yeah, and you've done little fragments of it on the World Network. So those are nice sneak previews for the full story here. And the one big lesson I learned, I think you talked about it in the first or the second time I was here, was about any given day, that arc of the sun is going to be the same angle. So that's the part, if you can not have to track that, you just already have it set at that, then it is just the one angle. So that's huge. Simplifies things a lot. And the law of diminishing returns, the bigger the bowl, every 6 inches probably doubles the price after that.
Yeah.
The other point I just want to emphasize is just about everything you talked about is the Chris Hackett principle. Of don't buy new, buy used, just go dumpster diving. It's all obtainium, the stuff you can obtain. So it's way cheaper, sometimes free, and you can do the same stuff with all those materials. So, and that's what you've done here. Wow.
Well, and this thing I made, with some of this stuff you can probably tell. I went to our local makerspace, and so I drafted this up first at home, and then I went there and etched this onto a piece of plywood. Some of this was cut on the plywood, but then I decided to bring it home and cut it all out here in my wood shop with a variety of tools and sand it down and such. So it's easy to make, but I've also discovered that there's this whole world of people making things with laser cut plywood, but much thinner, and they make them almost like little trusses and snap together. And I thought, I wonder how much of this I could do much lighter weight, because this is 3/4 inch plywood, which I think is good because it's not, well, the table is, sorry, the table is more rickety than this, so it's got a good stable base. But still, is it, how portable is it? These two I don't have the mountable at the moment. I mean, you could take the screws out, but this piece comes right out. But I really was delighted. I was when I came out with the idea of making this ark and suspending the pot there, because I actually started building a big frame, something that would stick in the ground or mount here and be like an arm to cantilever it, and that would work. But every time you change the elevation, or the latitude, which admittedly isn't very often, that would have to be adjustable.
Yeah.
And I thought, well, as a commercial product, I'm not trying to make this commercial, but I'm trying to find something that could be commercial.
Yes. Yeah.
What would make it work? And so the idea of making this an arc, so if that's 30, then it'll be 30 here and suspended at the 30, or
Yeah.
So that would be really easy. And then this would just suspend there, and probably I would do actually a 3-point. I'd probably do a third one here, so you get a full half to take this on and off, but there would be a third one that would be. And then the other thing I liked about that is if it's suspended, you could also even rotate it, because as you know, in certain times of the year, if the sun is really coming on one side of the pot, then being able to rotisserie the pot makes perfect sense too. So that would be presumably pretty straightforward to do there.
Well, and then the sundial, if people start with that, they'll understand the whole thing about, what is it, 17 degrees is the maximum, from the lowest to the highest?
Yeah, 23 and a half.
23 and a half, okay.
Yeah, in fact, when I first started doing this, I wondered, well, couldn't I just take 30 degrees here, and let's say it's June 21st, and couldn't I just take the 23 and a half off of there?
Yeah.
And couldn't I just do this and take the 23 and a half from there? Wouldn't that work? And I researched it and studied it, and the answer is, from about 10 to noon, or from about 10 to 2, yeah, it's pretty much identical.
Yeah.
But as you get closer to the beginning and end of the day, those arcs diverge. And I saw a very good YouTube video about a guy who was doing this 3D simulation explaining the differences. He was talking more about if you're doing for solar panels, for PV arrays, but it's the same idea.
Sure. That
people who essentially do this, I forget the word he used, it works. It's simpler, but it's not really the way the sun's path works. Yeah. And incidentally, on that topic, so we're at 30 degrees latitude. So if we set this to 30, just for everyone, of course, 90 is straight up. If this is now 30, that means it's up 60.
Right.
Okay? 90 minus 30, so we're at 60. And then from there you go plus or minus 23 and a half for each solstice.
Yeah.
So that's how you can do the math. So even if you don't even have to look it up. If you know your latitude, then you can take 60 plus 23 and a half. It tells us 83 and a half is the highest at the summer here, and then minus 23 and a half is the lowest in the winter here. So, I mean, of course, you can look that up too. And incidentally, pointing this toward the equator, phones nowadays, if you have a compass, which all phones do, have a compass app, and you can pick. There's an option where you can tell it, do you want to use the magnetic north or true north? And so, of course, we want true north. So you set this to. Of course, we know. I know south is actually that way, but so again, setting this up and trying to aim it toward the equator. Anyone who has a phone, it's not hard to do. So. I think that's about all the stories I was planning to tell today.
Okay. Yeah. We got a little back talk from the BNSF 935 run. But,
sorry about that.
No, I think it'll come through. It's and this should be okay too, especially since you're pointed away from it. And so I can't think of anything else. I mean, you covered so much ground in a very concise amount of time, and I can't wait to slice and dice all three of yours for the section on all this stuff. Selecting materials, the angle of the sun. It covers so many topics. So thank you. Thank you.
Oh, thank you for coming. It's always a delight.